Now let's look at the fourth question, the average daily high temperature in Yellowknife. It can be modeled with a sine function to simulate this information. The equation y is equal to a times sine b times x minus c plus d, where a is the amplitude of the function, b is the period of the function, c is the phase shift of the function, d is the vertical shift of the function. Now let's calculate them. The amplitude of the function is half of the difference between the maximum and minimum values of y. In this case, a equals 22.5. The period of the function is 12 months, since it takes 1 year for the temperature to go through one complete cycle. Therefore, b equals pi divided of 6. The phase shift of the function is how far to the right or left the graph has shifted from its usual position. In this case, we can see that July corresponds to x equals 7. Therefore, c equals 7. Finally, d is simply the vertical shift of the graph. In this case, d equals 0. Putting it all together, we get y equals 22.5 times the sine of pi over 6 times the quantity x minus 7. Now let's talk about the question 2. First, we have to sketch a graph. To draw the graph, we need to understand the movement of the passengers on the Ferris wheel. The height of the passenger from the ground varies sinusoidal with time. At the start of the ride, with t equals 0, passengers are at their lowest point. As the Ferris wheel rotates, the height of the passengers increases until it reaches its maximum height halfway through the cycle. T equals 12 seconds. And then returns to its minimum height at the end of the cycle. T equals 24 seconds. This cycle is repeated with each rotation of the Ferris wheel. The figure looks like a sine wave that starts at the lowest point, 1 meter, reaches a maximum at the top of the Ferris wheel, 11 meters. So we have this graph. The diameter of the Ferris wheel plus the distance from the ground to the bottom of the Ferris wheel, and then returns to the lowest point. Now let's turn to the question B. In this Ferris wheel problem, we choose to use the cosine function to describe the passenger's height change over time. Because the passenger is at the lowest point of the Ferris wheel at t equals 0, that is the moment the passenger starts riding the Ferris wheel, which is consistent with the property that the cosine function reaches its maximum value at t equals 0. If we choose to use the sine function then at t equals 0, the passenger will be the center of the Ferris wheel, which is not in line with the actual situation. Now let's calculate each part of this equation. First is the amplitude. Now let's calculate the amplitude. It is the maximum minus minimum, then divide by 2, which is 5 meters. Then it is the frequency. The frequency determines the time required for the Ferris wheel to complete a complete rotation. In this problem, the Ferris wheel rotates once even 24 seconds, so we can calculate the frequency by 2 pi period. So we can calculate the frequency. Then we need to know the phase. In this problem, the phase is 0 because the passenger starts riding the Ferris wheel at t equals 0. The last one is the vertical displacement. Vertical displacement is the height of the center of the Ferris wheel from the ground. That is 6 meters. That is the maximum plus minimum, then divide by 2. So we get 6 meters. Above this, we can know the final equation. For t equals 12 seconds, we can substitute the value of t into the equation to calculate the height h at this time. First, we can substituting t equals 12 into the equation. Then the equation can be simplified as since cos pi equals minus 1. So we can get the height is 11 meters. This is a good checkpoint because at this point of time, passengers should reach the highest point of the Ferris wheel. In addition, t equals 0 seconds and t equals 24 seconds are also good checkpoints because at both times, passengers should be at the lowest point of the Ferris wheel. When t equals 0 seconds and t equals 24 seconds, the height of the passenger is both 1 meter. This is in line with our expectations, as both of these time points are the moments when passengers are at the lowest point of the Ferris wheel. Now let's talk about the question 3. First, we need to determine the various parameters of the cosine function. The amplitude is A is half the difference between the highest high water and the lowest low water, which is 6.4 meters. The vertical displacement C is the average of the highest and lowest tides, which is 10.9 meters. Since the period of the tide in a day is 12.42 hours, so K is 2 pi divided by 12.42. The phase displacement D is the time when the highest climax occurs, which is converted to 8.35 hours. So a model of tidal height can be written as, in this model, ht is the height of the tide at the pier, and t is the time of day in hours. Now let's calculate the height of the tide relative to the pier at half of the 11. That is t equals 11.5. We can put this in the equation, so we can simplify feet to. In the end, we can know the tide level at the pier is about 10.8 meters. Now let's talk about the question D. We can use the demos to solve this problem. Now as you can see, I graphed the y equals 12 and the equation of the model of tidal heights. The boats need a depth of at least 12 meters to dock at the dock. Solving the equations, ht equals 12. We can get t equals 5.59 and 11.11. These solutions represent the time when the tide reaches a height of 12 meters. So the final solution is the boat can dock at approximately 5:35 and must leave at 11:07.